Okay, so in this part, we are going to look at the relational databases concepts as well as the relational database modeling. That means basically the basic steps of designing relational databases. And then we will also look at the implementation of relational databases using popular open source database system MySQL. Right. So let's start with the very first one. What we need to know is what a data is. We are in a data-driven society. Everything will be recorded. And that's basically, we can say, the known facts will be recorded. And database, on the other hand, we can see it as a collection of related data. For example, let's take a university environment. We will have to collect data about the students, the lecturers, the courses, payments, and so on. We call it related data, right? So starting from a collection of related data, if you think about the intended application and the users, okay. So for example, if we take the university environment and we have a student management system, for example, then we have different users, okay. So as I told you earlier, we can have facilitate users, that means our students, then lecturers, and also maybe some administrative staff. And each and everyone has different requirements from the database. And we build this for a specific purpose, right? So ideally, the software system that we create or the data that we are going to store will represent some aspect of the real world and physiologically organization. And then if you take database management system, the term DBMS, we use not just the data, but the software that we need to create and maintain the computerized databases. So in typical database application will support or will have facilities to create database. We call defining the database. So we can create files, records, fields, and even the links, which combines different records together. And you can construct the database and then you can manipulate, right? Meaning like you can insert the data, you can delete and modify. So this is what we see in a typical database management system. And we normally say, when you take together database management software and the data together, we call it a database system. The next thing is when you take any database system, then you will have set of functions. You have functions for defining the database. You have functions for construct, that means the create. And then you have functions to load the database, whatever the data is in, maybe in the text files or in CSV format, you can load the database, right? And then you can manipulate. Once you have created and load the data, you should be able to use or satisfy your data requirements. We call manipulate. So you can use it for retrieve the data. You can use it to generate the reports. You can insert, delete, update, right? So that's we call manipulating. Now, once we have a database system in place like this, then these data can be used by many programs. It's not just one program. It could be used by many programs and many users at the same time. So therefore, any database should support what we call concurrent processing. That means multiple users, multiple different programs should be able to access the data without violating the existing data, right? So You have typical functionally available for concurrent processing and share in the database. Right. Then we can look at the overall architecture of the database. So this is a simple graphic which shows about the simplified version of the database management system, right? So in this particular case, you will see the users in the top and you can see the data in the bottom. Actually, when we say data in the bottom, you have actual data in one side, we call stored database. And then we have data about data, we call metadata in another. So although we say it's just a database, you have two parts. You have actual data and you have data about data. We call metadata. And to users to access these data, you need several programs. For example, we have to have our own software to access the data. We call application programs. Or we can directly access through SQL, for example. We call queries. But for that, you need to database management system. You have to have a database management system support. So you can notice here, right, in this part, you will notice that's in the middle part, we have the DBMS software. We have software to process your queries or programs. So application programs or the queries coming from the top through the users should be processed, should be converted into a piece of code which understood by the operating system. And in that way, you are going to access the stored data. So that's what normally we will see in a typical database system environment. Right. Now let's look at some example data. So for that, what we can have is a simple database which shows you some data and how we store the data. In this particular case, we are going to look at the university database. And the data is actually separated. We normally put into tables. So you can see we have a student table. Although we have two reports, we have student, we have Smith and Brown, which represent the student table. Then you have course table. Similarly, you can also notice section and then also grade report and prerequisite. So what this shows you is you will have data in related tables, right? We said related data, what we have in a relational database environment. And if you look at carefully, you will have data elements as well. I'll come to this point in again. So you can notice that each table you have different elements, so the fields like name, student number, class, major, and so on. And each of these data also have a type. For example, if you take student, we have name of the student and it will be a string data type. If you take student number, for example, you can take it as an integer, for example. And if you take grade, it could be just one single letter we call char or single character. Right. Next, we need to understand different types of data models available. Right. So we'll start with the data model. So data models we will use to describe the structure of the data. Now we are discussing relational databases, and what we are going to talk about is relational data model. So when we say a data model, as I told you earlier, which will describe the structure, it also has some of the constraints which the database should obey. And then we can define set of operations, right? So these operations will specify how you might retrieve the database, how you might update the database based on the concept related to the data model. So there are some basic operations as well as user-defined operations. Now that we discuss about the data models, the next thing that we need to discuss is different types of data models. We can define different categories of data models. So we can define three types at least. Conceptual, which is very high level. Then you have physical, we normally call low level, internal. Or you can have implementation. Right. Now, when you talk about the conceptual data model, so that actually gives you a very high level overview of the data. So you can say that how users may see the data, right? That's what we are going to discuss today, conceptual data model using ER diagram we call entity based or object based. Then we have physical data models. This will describe how data is stored inside the computer. We call low level internal data model. And the third one, implementation will be in the middle of these two. Right? So this will give you a view of both user views and some of the storage details. So in both, we call implementation data model. Right. Now that we have looked at different types of data models, we can talk about three schema architecture. So in our case, three schema meaning like there will be three levels of data when you're storing. So you have a internal level, we call internal schema, which refers the storage details, storage the stored database. Then you have conceptual level, which is in the middle, and the external level, where how different users actually interact with the database. So this is called three schema architecture. In three schema architecture, we can talk about the internal schema, how the physical data is stored. That is what you notice in the down here. Then conceptual schema. Ideally, we will explain the different constraints and also the structure details. And the external schema, which we represent in the top, how users see the data. Now, what I want to highlight here is different users get access to different data, right? Depending on the access they have, they will see different views of the same data. For example, if you take a normal user, we will give you access to just to insert the data. So he will, for example, in a university database environment, the person might have access to the student details, basic ones. But if you take a higher level user, let's say manager, for example, might have access to all the data, right? So likewise, we can define different views. Right. Now that we talk about the three schema architecture, we are going to discuss very important idea, which we call data independence. Now, these different levels we can change, right, without affecting the other levels. So we talk about two types of data independence, right? We say logical data independence, meaning like we can change the conceptual schema, which is in the middle, right? Without having to change the external schema, what is in the top. So what you can see here is you can change what is in the bottom without affecting the what in the top, right? So when we say conceptual schema, it will be in the middle one. We can change that without affecting our external programs. Similarly, you can change some things in the inside without changing the conceptual schema. Right? Now, for example, you can add some columns without affecting the user programs. Similarly, you can change some indexes. Indexes means efficient access of the data without affecting the conceptual. So this is called physical data independence. Right. Now that we got some basic understanding about the data models, structures, and data independence, let's look at some data classification, database classification. So you will notice there are lots of different database management systems out there, right? And there are many ways that you can categorize them. So one way to categorize based on the data model, right? So in traditional databases, we have relational, network, and hierarchical, and we are discussing relational database system, which starts around like 1970s and come, right? Still we use relational database. But we have emerging ones, object-oriented, object-relational, and even new ones like NoSQL databases, right? That comes as new data models. Second, you can classify the database based on the number of users. So in typically old days, we had just single user. But of course, now many users can access the database. So we can classify the databases as single user as well as multi-user. Next, we can classify based on the number of sites database distributed. Now you know that when you are accessing data, for example, when you search, maybe let's say you do a Google search, you get millions of the results, the records within a fraction of a second. If you look at how this is possible, the data coming from multiple different sites, right? So if the data stored is just one single place, we normally call centralized database or centralized system. If the data is stored in a distributed manner, that means in different places, different locations, we call distributed. And what we have nowadays, mainly, the data will be stored in multiple different places. We call distributed databases. So with that, you can serve many users who are in different geographical locations. Okay, the next, you can actually change you classify the database based on cost. So you know already there are some databases are free and open source as well, and the others are commercial. So these are like some of the ways that we can actually classify databases. Right. Now let's look at the database design process. So I would like to discuss how the database is designed. What are the basic steps? Right. So the next section, I'm going to focus on how do you design a database. Right. Now, first thing is we need to understand the database design process. So ideally, during the design process, we are trying to answer a problem. What is the problem that we are trying to answer? We are trying to accommodate information needs by different users in an organization. So when you say a database design, you have to design the logical and physical structures. I'll come to that. And you have to create maybe one or more databases. So by designing a database, we are trying to meet different goals. One, as I told you earlier, different users has different data requirements. So we need to satisfy basically content requirement, the data requirement. Second, we have to provide the easy structure. Structuring data is very, very important. Third, we need to support the processing requirements. For example, if you want to retrieve some data, and if it takes like minutes, hours, weeks, it's a problem, right? We need to retrieve data as soon as possible. As I told you earlier, in Google queries, you will see you are getting millions of records within the fraction of a second. So we have some processing requirements and performance, right? So you have to support it, right? If you think about like application like share market, for example, it really matters how you design the database, right? Fraction of a second is also matters. So basically it depends on the application you design. Right. There are different phases in database design. So let's first try to understand what are the steps, what are the phases available in database design process. So the first one will be the requirement collection. So when we say requirement collection, so we have different users have different requirements, right? So there are a few things that we have to think about this. Next, you have to conceptual database design, right? That means very high level database you are going to design, right? Two things we are going to discuss under this. Third, you have to choose a particular database management system. Remember, we discussed different types of databases, different classification. So there are many factors that you have to consider when you're choosing a database management. We'll discuss. Then you have to map the model mapping. Remember, we create a conceptual database design, very high level design. You have to map it to the based on the selected database with the requirements, right? So the high level data model, you have to make it to the model that you have selected with the database. So that is what we call model mapping. Then we have physical database design. Now, physical database design means like the data will be stored inside the computer. You need to efficiently extract the data. So we have to focus on the storage details, storage structures, right? Things like indexes, transactions. I'll come to that again in detail in coming slides. And the last one is database implementation and tuning. Basically, you have to implement and you have to tune, meaning like you have to look at the performance of your queries, like how fast it will execute and how do you improve the timing and so on. So we have to look at all those aspects, right? So if I show you like graphical representation of this, so here is how you can see the phases. So you can see all the 6 phases here, starting from requirement collections to system implementation and tuning. And remember, you see there are 2 parallel, paths. One is we have to focus on the data content, structure, and any constraints. What I mean by constraint here, like, for example, we have some limitations. For example, let's say you are trying to store the data. How much you can store will be limited, like there are some constraints. If you go with the record level, maybe there are possible values that you can store. All these things comes at the first part, that is data content, structure, and constraint. And the second part would be the applications. I told you, like, you have data as well as you have different applications as well. So the database application also you have, come in parallel, right? So focus on the phase one. If you focus on the phase one, you will see data requirements in the data content side, and application side, you have processing requirements. Similarly, if you go to phase two, then you have a high-level database design, we call conceptual design. And this design is usually dependent of whatever the database you are going to use, right? And the application side, you have to look for transactions. What I mean by transaction here, when you want to do a particular task, it involves multiple different, access. Let me give you an example. The typical example we normally give for transaction is a ATM access. Now think about that you are retrieving money from your account through an ATM. So when you do that, there are multiple things processed at the same time. So let's say that you are retrieving, let's say, 1,000 rupees from your account. So remember that before you issue money through the ATM, you have to deduct the money from the user's account. At the same time, if the money is attached to a particular ATM or a bank, you have to deduct the same amount from the bank account as well. So you can see that one transaction affects multiple different data. So this is called transaction because there will be a set of operations. The idea is if something goes wrong, let's say there was a power, there was a breakdown. Either you have to execute everything or none at all, right? That means if you have, let's say, in my previous example, we have two operations. You have to deduct money from the user's account. You have to deduct money from the bank account. So two operations. So if something fails in the middle, either you have to execute both or not at all, not partially, right? If you have execute partially, then your database is, we call, inconsistent. So, right, phase three, phase four, phase five, you can notice the other ones. Phase three, you choose the database. Then phase four, we have to map it. All the requirements that you have identified as a conceptual design should be mapped into logical design. And this is database dependent, right? Depending on what database you have selected, this will be different. And then you have physical design. You have to design the indexing structures, right? What database engine, storage engine you are going to choose. Everything you have to design at physical design phase. Last one, you can notice that different implementation details. We have data definition language and storage defining language also is there. And then on the database application side, we have transaction and application implementation. So that's parallel executing. Right, now that we have got a brief idea of what is happening, let me give you more details in each of these phases. Right, starting from the first phase, which is the requirement collection and analysis. The very first step is you need to identify different types of users, right? So you identify different types of users. I told you the different levels of users. And then you have to interact with the users. You have to gather the requirements, their data requirements. Usually this phase takes quite a lot of time. That's why we say it's time consuming, but very important. Why we are saying this is later stage. If you are missing some requirements, to fix it, it takes some time. So therefore, right, you should, spend considerable time identify exact requirements from the users. Then using that as the next stage, we call conceptual database design, right? You need to come up with a high level overview of the database. And as I told you earlier, it's independent of any particular database management systems. So this has like two tasks, two parallel activities, conceptual database design as well as transaction and application. So in the data side, you design the high level architecture. And then also you have to focus on what kind of transactions that you want to have. So that is what we call the transaction and application design. Third step, we call choice of the database management system. There are many factors you need to consider. You have to consider at least three. One, technical factors. For example, what type of database management system you want to have, right? Whether you have relational or object relational object database, or if you look at the recent, development, maybe you can think of NoSQL databases. Storage structures and architectural options. So these are we call technical factors. Next, economic factors. What do you mean by economic factors is, design a database and choosing a database. I told you some are free, some are commercial. So designing a database will cost a lot of money. So you have to look for the economic factors, data acquisition, maintenance, training, operating, all this you have to consider. And to create the database also, you have to consider. And conversion. What do you mean by conversion here is, if you have done everything manually up to now, you have to digitize them. And if you're using a different database system and you are going to migrate to a new database system, you might have to convert old database into new database. So you have to have a conversion cost. That is the second factor. Third, there are some organization factors as well. Now, some organization might prefer some databases. Maybe they might already have some database management systems, preferred database management system in place. For example, industry people, if you might have about the MySQL at the same time, the Oracle. The company Oracle also acquired MySQL up some time back, and then you have both. In commercial world, usually they prefer, commercial database. Oracle would be the choice sometime back, right, in the industry. So that comes with the organization philosophy, right? Some may prefer relational databases, some may object-oriented. Maybe if they want to have the newest, like, for example, they want to store some unstructured data, maybe they have to go for new database like NoSQL, like MongoDB. And sometimes they might have vendor preference, as I told you earlier. If they have already used Oracle, maybe they prefer Oracle. Right? So it totally depends on the organization. So the familiarity of the staff with the system and also the availability of vendor services. Some might have already providing services for the particular organization. Then they might consider using the same. Right? So likewise, there are many factors we need to consider when you talk about choosing a database management system. Right. Now, once you choose the database, now you have to map it everything. This is called logical database design. Now, what do you mean by logical? Once you have designed, let's say MySQL, then you have to transform your database requirement into that, right? So that's why it says you have to transform a schema from high level to the data model you have selected DBMs. Now, for example, if you are selecting a relation database, you have to convert your requirement to relations. But if you select something like NoSQL database like MongoDB, it will be different. So in relational world, we have different requirements. And NoSQL, for example, you have different set of requirements. So therefore, I mean, it totally depends on what you have chosen from the previous step. Right. And the second point is you have to design external schemas for the specific applications. So once you have selected databases, right? So the data will be accessed from different applications. And then for that, we have to design. Okay, there are two stages. One is system independent mapping. So the database management system independent mapping is there. And then you have tailored the schemas to specific DBMs. So you have to adjust schemas to confirm the specific implementation of the selected data model and the selected database management system, right? Ideally, you will have a set of, for example, in relational database, you have a set of SQL statement which you can use for this. Right? Okay, next we have physical database design. So under the physical database design, that we can design how you exactly store the databases. You have physical storage structures. For example, in MySQL, you have MyISM, InnoDB. Like there are some storage structures which provide different, features. So depending on our requirement, we have to use them. For example, if you want to use transactions, you have to use InnoDB, right? If you do not, then maybe you can go with MyISM. Likewise, there are different storage options. And how you place the record and how do you index them. Indexing means you have a storage structures. We create storage structures so that you can efficiently access data. So what fields you are going to use for the index and so on, you have to, decide in this stage. Right. Now, there are a few things when you're designing, we call design criteria. One, you have to focus on the response time. That means the time it takes to submit a particular query, and then you are receiving the response, the time it takes, the space it takes, right? And the transactions. So the transactions are the one happening. I told you, like when you're making a change in the database, there are multiple things executed within this. So how many transactions you can perform per minute, we call throughput, is very, very important. And when you're doing so, you have to focus on the peak conditions. So ideally, the outcome of this stage is the initial determination of the storage structures and access path for the database files. Last phase, we call system implementation and tuning. So once we have decided the database management system and after implementing this, right, you have to test, implement, test, and deploy, right? From the previous step, you have identified all the required SQL statements, storage structures. Now you have to implement and you have to test. And if you are comfortable or if you are satisfied with the test results, then you can really implement. You can deploy, meaning you can give it to client side. But then it's not over. Ideally, once you deploy the system, you have to always monitor and tune, right? So you have to monitor the system. So you have to monitor the performance. And then based on that, you are going to make some changes. So data indexing, reorganization are typical tasks done during this time, right? And it will not just, single time, it's always continuous process. Right? Things might change, things might, ask you to implement. So then you have to work on over and over, like maintaining in something. Right. Okay. So with that, I think we have now understood what a relational database management system is, its basic architecture, and also the database design process. What we have observed is there are a few phases, and each of these phases we focus on different aspects of the database requirements or database creation. Right. Now that we have understood the process, I would like to discuss the remaining part, the modeling part. We are going to practice and learn database creation part. So first thing we need to know is we have to build a high level overview of the database. So this is called data modeling. So the next part, the main part for today, I'm going to focus on the database modeling. We call data modeling. And when I say data modeling, actually we are focusing on relational data modeling. Right. Then there are many different techniques people actually use for modeling. And out of that, we are going to focus on what we call the entity relationship model or ER model. Right. So in this part, we are going to discuss about the high-level conceptual data model. I told you this is how the users will perceive the database, and this is called conceptual schema. And there are many, but we are going to focus on just one, a common one. Everybody should familiar with, which we call ER model, right? We call entity and relationship model. So the world, we are going to view as entities. For example, in the university environment, we can see student as an entity, lecturer as an entity, course as an entity. And there are relationships. For example, lecturer taught courses, and the students take those courses or follow those courses. So those are called relationships. Right? For example, I can take employee, it's an entity. Organization is another entity. And employees works for the organization. The works we call the relationship. So we can define entities and relationship when you're designing a database application. Right. Now, once you follow the data ER modeling, the outcome of this is called ER diagram. So in database design, as the very first step, we normally create what we call the ER diagram, which represents the basic conceptual level database, right? So what we are going to look at is we describe all the data requirements as entities, relationships, and attributes. Right. Now, to explain this, I will take a small example. So in this part, what we are getting is a simple database description about a particular company. Right. Now, let me give you the description first. So this is the description. So this description will describe particular data requirement of a company. This is called company database, and I have taken from the Navates book. And using this description, we will understand the creation of a ER model, right? So using this, we are going to create a diagram like this, and this is what we call the ER diagram. So those who have already learned the databases, you might be familiar. There might be differences. There might be differences in the notations because many different people come up with the different notations. So therefore, that might be different, but the core concepts are the same, right? Going back to my previous one, this is the description, right? Ideally, this will you will create a similar description when you gather user requirement. So to create a description like this, ideally you talk to different users of the system, collect their data requirements, and you have to write down their requirements. And this is how you might get a description like this. So this is a toy one. So let's try to first understand what is important once you get a description like this. Right. So let's go one at a time. Right. So starting from the first one, it says a company is organized into departments. And then it describes the department. It says, okay, each department you have unique name, unique number, an employee who will be managing the department. And it also further describes its requirement. We keep track of the start date of the department manager, and department may have several locations. So basically, you can notice that I have highlighted in red color and capitals the department. So basically, this is the entity, main thing we are describing, and these are the piece of data which is very interesting, right? Next, another point which describes another entity. Each department controls number of projects. Each project has a unique name, unique number, and a single location. Right. So as you can see, I have highlighted here in capitals the project. So basically, this will describe about the project entity. It's called entity type actually. And it also describes the data. Project has a unique name, number, and a location. Third one, we store each employee's name, social security number, address, salary, sex, birth date. Each employee works for one department but may work on several projects. We keep track of the number of hours per week that an employee currently works on each project. We also keep track of the direct supervisor of each employee. So you can notice here, it's highlight the employee entity. And these are the data requirements. Social security number is like our national identity card number. And then you have other related attributes. And then your relations are described here, right? Last one, each employee may have number of dependents. For each dependent, we keep their name, sex, date, birth date, and relationship with the employee. Right. So I think now we have some idea about the database requirements. Okay, now let's focus on the core ideas when you're drawing a ER diagram like this. Right. First one is you need to understand what entities are. So entities are like specific objects or the things that we want to represent in a database. For example, when you take a particular employee, let's say the name of the employee is John Smith, we call it an entity. When you talk about a department, let's say a research department, it's a particular entity. When you say a product, it's project, a particular project, that we call entity. And each of the entities are described using attributes. For example, if you take an employee, we have already seen from the description, you have to have a name, social security number, address, sex, birthday. These are called attributes. And each of these entity, you have values. So for example, here we talk about the employee entity. So you have name, so John Smith. You have a social security number. You have a number which describes his social security number. You have address component and date of birth. So these are like we call values for a particular entity. And if you take each attribute, the values come from specific value set. For example, if you take name, it's just set of characters. If you take gender or sex, you have male and female. It comes from two types, male, female. So that means any attribute you have different data types concerned. It could be an integer, it could be a string, sub-range, enumerator type, and so on. Right. Now focusing on the attributes, there are different types of attributes are there. You have something called simple attributes. You have just one value. If you take social security number and maybe the gender, you have just one value. We call simple attributes. Then you can have composite attribute. You have several pieces. If you take name, for example, we can divide it as first name, last name. If you take an address, you can have, address line 1, address line 2, and so on. So when you take an attribute where you have several components, we call it a composite attributes. Then some attributes might contain multiple values. For example, if you take a color of a car, we have two tones nowadays, right? You have multiple colors. Or if you take like the number of degrees that you have earned, right? So you might have multiple degrees, multi-value. We call multi-valued attributes. Then you have derived attribute. For example, we can store date of birth, and let's say we want to calculate age. So the age we call derived attributes. Similarly, number of employees in a department is a derived one. So that means from using whatever the existing attribute, if you can calculate or you can derive, we call derived attribute. Okay, so these are the different types of attributes available. Sometimes you will notice these attribute types can be combined. For example, composite and multivariate can come together. For example, if you take your previous degrees, you have a university usually where you have obtained the degree, the year you have completed, the degree name, and a particular field. These are describe the previous degrees. So you have a composite attribute, right? Composite means you have multiple different type, pieces which describes, and then you can have multi-value. So that's why we call it's a composite multi-value attribute. You can have both. Right. That's about the different types of attributes you can have in here. Right. The next thing is some of the things that we will describe. Now, entities, now we understand. And when you put them together, we call entity type, right? All the entities, when you combine together, we call entity type. So earlier we say entity. When you take a particular person, John Smith, we call entity. But when you put everybody together, we can say employee entity type. And the ER diagram, usually we represent entity types, not individual entities. Similarly, project entity type. So we said product X project. It's an individual entity. But when you combine all the projects together, we can say project entity type. Right. So in ER diagram, we normally represent entities. And usually for that, we are using rectangle box. Right? So I'll come to the representation. So each of the entity types we represent using a rectangle box like this. Right. The second one is once you identify all your attributes, you have to identify unique attributes. Unique attributes means you have just unique values. These are called key attributes. And ideally, we have to underline all the key attributes. right? Now, for example, if you take in our employee, the key attribute is social security number. It's a unique value. When you have unique values, then you underline. So for that, actually, what we represent is like when you have entity type like this, we will use oval shapes to write down all the attributes, and we can connect using the lines. So for example, let's say you have student and student name. You can connect here, student name here, which represents the attributes. But let's say if it is a unique one, you should underline, which is we call key attribute, right? Right. Sometimes your key attribute might be composite. That means you can have like multiple components, right? For example, vehicle number sometimes composed of two parts, the number and the states, right? And when you combine the two, you can make it a key attributes. Another one is you might have more than one key. For example, in Sri Lankan setting, if you want to identify a particular person, you can use national ID card number. You can use passport number. You can use driving license number. So all these considered as key attributes. So remember, in ER diagrams, you can have multiple key attributes. Right. Going back to my description. So can you see here? We have each department controls a number of projects. So this is the entity type. And then if you read along, each project has a unique name. So the name is attribute and it's called unique. So it is a key attribute. And then it says it's a unique number. Again, a key attribute. You have to underline, right? And it will be in a single location. So going from this to the diagram, can you focus here? We have project. This is the entity type. And you can see here attribute name, underline, attribute number, underline, the location. So therefore, you can notice that there are two attributes, underline one, which indicates key attributes. What do you mean by key? It's unique, right? That's all. So you can have multiple unique attributes attached to a entity type. I hope you got the point that I want to highlight it. Right, right. So these are the graphical symbols we are using. What we have discussed so far is entities and the attributes. So I think I explained the entity here, which is a regular entity. We call it a rectangle shape like this. And then attributes, if it is a key, you will underline. If you have multi-value key, what do you mean by multi-value? If you can have like more than one value, right? Then we use double oval. I said the color of car, right? So if you have color attribute attached to the car object, so car identity type, then you have to use double oval like this. If you have a composite attribute, that means if you have an attribute with multiple components like address, like a name, then you can put like this. You have, let's say, name, you have first name and last name. If you have address, let's say you have a street number, address line 1, address line 2. So that you can represent like this. If you have a derived attribute, that means you can derive it from another attribute. We use dash overs. Okay, going back to our previous one, let me show you some examples from this. So can you notice here we have employee. An employee, we have a social security number. It's a key attribute. It's underlined. And we have a name. So this will indicate that name is a composite attribute because you have several parts. You have first name, middle initial, last name. So this is called composite attribute, right? And if you go to the description of the department, you can say each department controls number of, sorry, not that one, this one. The company organized into departments. Department has a unique name, unique number, and employee who manages the department. We keep track of start date of the manager. A department may have several locations. Can you notice here? It says several locations. So if you look at the representation here, we have department. You can see the name is unique, underlined. The department number is unique, underlined. You have several locations. So it's a multi-valued attribute. We have used double over here. And also notice the number of employees represented inside the dash line because it's a derived one. How many employees there can be derived from whatever the information available. So that particular attribute is represented using the dash over. Right. So I think now you might be comfortable with the entity types and also the different types of attribute. Right. Then we are going to focus on relations. So when you talk about the relations, we talk about the relationships. What do you mean by relationship? It relates two or more entities, right? For example, we can say employee John Smith works for a particular project, let's say product X. So this works is a relationship. Employee Franklin Wong manages the research department. Manages is a relationship. So whenever all the relationships combine together, all possible employees works for different projects, we can create a relationship type. And the relationship types we represent using diamond-shaped blocks. So you can see here, relationships, we use this symbol. Right. Now let's go back to our ER diagram and let's see what are the relations we can find out. So you can see here, we have employee and department. And employees works for department. So you can see here, works for. Right? This is a relationship which describes employees with the department. Employees works for department. Similarly, you can notice some of the employees, they manages the department. Can you notice here? If you look at these two entity types, you can see there are multiple relationship types. Employee works for departments and at the same time, employees manages department. Okay, so that's the first part. Then, depending on what kind of relationship has, we can define something called degree of a relationship. So when we say employee works for department, we have two entities or two entity types are participating. The works for relationship type. So if you have two, we call binary relationship. If you have three, then we call ternary. Actually, you can have n-ary as well. So our description is a very simple one. We talk about only binary relationships, but you can have any. Right. So here we will talk about when you take same entities, you can have multiple relationship types. I already showed you from employee to department, you have two relationship types. One works for, one manages, right? The next one I want to discuss is weak entities. Now, so far, when we discuss entities, we talked about key attributes. What do you mean by key attributes? A unique attribute you can use any entity type. But sometimes when you talk entities, they don't have any key attribute. So then this is known as weak entity. Actually, we call weak entity type, right? So then you have to when you don't have a key attribute, you have to have a participating relationship. The existence of a weak entity type depends on what we call the owner entity type. Right? Let me describe this idea in the diagram itself. So if you go back to our description, right? The department, the project, and the employee all are regular entities. We call entity types. But the last one, if you look at the attributes, there's no unique attribute you can find here. Name, gender, date of birth, relationship, all they are not unique. So when you don't have a unique attributes, when you don't have a key attribute, this is called a weak entity type. So that's why we have a rectangle with double lines. So this representation indicates that this is a weak entity type. And this is actually depend on the owner entity. You can notice the relationship here is with the employee, right? So without a particular employee, there's no existence for this dependent. That's why it's weak. So ideally, you can see a dash line here. We call a partial key. And using both the key attribute from the owner entity, which is social security number, and then this partial key combining together, we can form a primary key. When we transform, we discuss the idea. So therefore, since this is a weak entity type, this is called participating relationship type. And you can notice that this is always double line, that is weak entity type, and also the relationship type. So this will be always double line, which will represent that the dependency here, the identifying relationship. Okay, now that we have discussed about the relationship types, right? We can move on. So we discuss about the weak entity type here. Right. Now, weak entity type, as we discussed already, you might not be able to find any key attribute, but you can identify these entities by using what we call a partial key. So the name of the dependent is a partial key there. And then attribute coming from what we call the identifying relationship, that is a employee entity type, right? Using both, we can actually identify each of the dependent uniquely. Right. Okay, let's move on. Now we have discussed about entities, then we discuss about attributes, then the relationships. Next thing is we need to discuss about their cardinalities. Cardinality means their maximum participation. We call maximum cardinality. We call cardinal ratio. So we can discuss one-to-one, one-to-many, or many-to-many. Right? So that means number of entities participating in a relationships. Right? So this is called cardinal ratios. So let's go back and we'll identify cardinal ratios in our case. So from the graph itself, you can notice if you take a particular employee works for one department. You see one here. Take the department can have many employees in here. So this is, we can say many to one or one to many relationship. Okay, let's take another one. Employee can manage a department and department should manage by an employee. So this is one to one. So it's always opposite. Take a employee can manage one department. Take the department, you have one employee. This is called one-to-one relation. So we talk about the maximum cardinality here. Okay, let's take another example. Employee can work for projects. So it's many. So here, take one project can have many employees. So this is called many-to-many relationship. So you can see M and N here, capital N and capital N, which represent that this is a many-to-many relationship, right? Then look at here, we have department and projects. Department controls projects. So take one department can control many projects. Take a particular project can be controlled by one department. So this is called one-to-many relation. Right. Okay. More relationship types, cardinalities. If you take one employee can have many dependents. So this have N. Take a dependent. It's dependent of one particular employee. This is one. So you have one to many. Okay, we have very interesting relationship type here. This is called recursive relationship type. So you can notice that employees are supervising other employees. So when you have a relationship type like this with the same, you have to, write down the role names. What I mean, the role name is you have to represent the different sides. So this is a supervisor side, this is a supervisee side. So if you take the supervisor can, supervise many supervisees. But if you take one supervisee, supervised by just one employee. So this is one-to-many relation. This is a very interesting one. Just to understand recursive relationship type and then also like cardinalities and the role names. Okay, so I hope now you are comfortable with the cardinalities, right? So we discuss about the cardinalities. Cardinality means whether it's a one-to-one, one-to-many, or many-to-many. So once you identify the entities and relationships, then you have to specify whether it's one-to-one, one-to-many, many-to-many, because this is what we use to map later on. Okay, last one, we call minimum cardinality. That means we are looking for the participation of each entity type in a relationship, whether it's optional or whether it's mandatory. So if the participation is optional, optional means that not all the entities are participating, we call zero, right? We use a just single line. But if it is mandatory, one or more, then we draw double lines. It's called minimum cardinality. So let me explain this again with the diagram. Right, now look at here. So all the employees works for particular department, right? So when you look at this relationship, all the employees works for department. So therefore, this is double line. It's not optional. All the department you have employees, so it's double line. All the departments you have managers, double line. But remember, not all the employees works as managers, only some of them. So therefore, this is optional. So therefore, you have a single line. So this is called total participation. This is called partial participation. Here, all the employees works for department. So this is total participation. Everybody participates. Here, only some of them works as manager. You know that not everybody can be works as managers. So there's only some of them. So you have just single line. Right. Now, similarly, look at here. All the employees works for project, so therefore you have double line. All the projects you have employees, you have double line, right? Then look at here. Both sides you have single. What it means if you take employee, right? Not all the employees are supervisors, and not all the employees are supervisees as well. That's why you have partial participation, the single line. Okay, look at here. Now we have department and project controls. So you can notice that projects, you have departments. It's compulsory. So all the projects you have a department. What this single line means that not all the department control projects, right? Remember the use of total and partial participation. Right. I think that's all what I have for today then. That's what I want to discuss. All the other things we have described. So just to summarize my discussion today, we discussed the basics of relational data modeling, and we discussed data modeling using entities and relationships. So one thing you need to remember, these ER diagrams will represent the schemas, not particularly instances. So that's why we talk about entity types, relationship types. So there are some recommendations. So I want you to also use these ideas. Use singular names, use uppercase letters for entity types and the relationship types. So you can notice we have used employee in all capital uppercase letters, departments. So those are entity types. Then we have relationships, works for, manages, all singular names and then uppercase letters. Attribute names use capitalization like name and salary. The first letter is capital. But if you have role names in the recursive relationship, then you can have the lowercase letters. Then coordinate ratios, whether it's 1 to 1, 1 to many, many to 1, many to many. This is the notation that we have used. 1 and 1, 1 and capital N and 1, and capital M and capital N. Participation constraint, we have used single line for the partial participation, double line for the total participations, right? And remember, sometimes when you're given a description, you might not be able to determine everything. So maybe you have to make some assumptions. Right, good.